January 1945. A cold wind slides across a Japanese airfield, carrying the sharp smell of fuel and unfinished metal. Mechanics step back as the engine coughs to life rough, uneven, almost angry. The aircraft looks familiar at first glance. Tout familiar. Its shape echoes an American idea. Copied in haste, reshaped under pressure, and forced into existence by a nation running out of time. The pilot does not smile. He tightens his gloves and listens not to orders. But to the sound of the machine beneath him, the vibration is wrong. The engine strains, even before the throttle is fully opened. He has heard the rumors. Everyone has. Wings that fail at speed. Engines that overheat without warning. Aircraft that look powerful on paper, yet terrify the men assigned to fly them. This plane was meant to be a shortcut. A way to close the gap with American air power by copying what seemed to work. But something essential was missing, something no blueprint could provide. As the aircraft begins its takeoff roll, fear settles into the cockpit. Not fear of the enemy, fear of the machine itself. By the final years of the Second World War, Japan's air war had entered a phase defined not by ambition, but by erosion. What began in 1941 as a force built on elite pilots, agile aircraft, and offensive momentum was now fighting a defensive battle against time, fuel, and an enemy that had mastered industrial warfare. By 1943, the balance in the air had shifted decisively. American aircraft production was no longer measured in hundreds, but in tens of thousands. New fighters rolled off assembly lines faster than Japanese intelligence could catalog them. Each new model brought longer range, heavier armament, better radios, and most critically engines that could endure punishment and still bring pilots home. Japan did not lack engineers. What it lacked was margin. Every loss mattered. Every veteran pilot killed was irreplaceable. Training programs were shortened. Flight hours were reduced. New pilots were sent into combat with a fraction of the experience their predecessors once had. At the same time, Japan's aircraft industry was being strangled by material shortages. High-grade aluminum became scarce. Precision machining suffered. Fuel quality deteriorated, forcing engines to operate under conditions they were never designed to endure. Yet the demands from above only increased. American bombers were appearing over Japanese cities with growing frequency. Long-range escort fighters accompanied them deep into territory once thought unreachable. Existing Japanese fighters struggled to intercept them effectively, especially at high altitude. Engineers were ordered to produce answers. Quickly, there was no time for long development cycles or experimental failures. In this atmosphere of urgency, imitation began to look like efficiency. Japanese intelligence carefully studied American aircraft through combat reports, wreckage analysis, and technical assessments. Certain features stood out immediately: streamlined fuselages, robust landing gear, heavy firepower, designs that favored speed, durability, and pilot survivability over extreme maneuverability. On paper, these aircraft represented everything Japan now needed. The logic seemed sound. If American aircraft were dominating the skies, then adopting similar design principles might restore balance, without the time required to invent something entirely new. But copying a shape, American aircraft were the product of an industrial ecosystem that Japan simply did not possess by this stage of the war. Engines were built to exact intolerances using consistent materials. Fuel quality was standardized. Replacement parts were plentiful. Pilots trained extensively before ever seeing combat. And behind every aircraft stood a logistics network capable of keeping it operational under relentless strain. Japan, by contrast, was attempting to replicate results without the foundation beneath them. Designs were pushed from drafting boards into production with minimal testing. Engineers were forced to adapt foreign concepts to domestic engines that were already operating at their limits. Weight increased faster than power. Cooling systems were stretched beyond safe thresholds. Structural stresses multiplied as aircraft were pushed to match American speeds without equivalent materials. And still, the orders continued. Aircraft were no longer expected to be perfect. They were expected to exist. By late 1944, this mindset had hardened into doctrine. New aircraft were evaluated not by longevity or safety, but by whether they could briefly mature, appear to match the enemy's performance. Short-term capability replaced reliability. Survival became secondary. Pilots noticed immediately. Test flights revealed troubling signs. Engines overheated, controls stiffened at high speed. Aircraft behaved unpredictably under combat loads. Rumors spread across airfields faster than official reports. Certain new machines earned reputations before they ever saw battle not as weapons, but as liabilities. Yet these aircraft were still assigned. Still fueled, still flown. Because Japan no longer had the luxury of choice, and it was within this collapsing framework, this mixture of desperation, imitation, and industrial strain that won Copid. American idea would be transformed into something far more dangerous than its original inspiration. A machine feared not by its enemies, but by the men ordered to climb inside it. By 1944, the gap between Japanese intention and Japanese capability had become impossible to hide. Aircraft design was no longer driven by doctrine or long-term planning, but by emergency meetings, improvised solutions, and directives that arrived faster than factories could respond. One of the most critical weaknesses lay beneath the skin of every aircraft. The engine. American aircraft design during the war revolved around power plants that were not only powerful, but forgiving. Engines were built to run reliably for long hours, tolerate imperfect handling, and absorb battle damage without catastrophic failure. Japanese engines, by contrast, had been designed around light weight and precision under ideal conditions. As fuel quality declined and maintenance standards slipped, these engines lost their margin of safety. When Japanese engineers attempted to replicate American performance higher speeds, increased climb rates, were forced to push existing engines beyond their original limits. Cooling systems became lubrication failures increased. Overheating was no longer an occasional risk. It became an expectation. Structural integrity followed the same path. American aircraft relied on strong internal frameworks designed to handle high-speed dives, abrupt maneuvers, and heavy loads. These structures were supported by consistent metallurgy and industrial quality control. Japan, facing shortages of high-grade aluminum and skilled labor, was forced to substitute materials and simplify construction methods. On the drawing board, the Copid designs appeared adequate. In the air, under combat stress, weaknesses revealed themselves with terrifying speed. Wings flexed more than intended. Control surfaces responded sluggishly at high velocity. At extreme speeds, precisely the conditions demanded during interception, some aircraft exhibited dangerous instability. Pilots reported vibrations that worsened as speed increased, a warning sign that structural failure was not hypothetical, but imminent. Then there was the issue of fuel. As Allied bombing intensified and supply routes collapsed, Japan's aviation fuel quality deteriorated sharply. Engines designed for high-octane fuel were now forced to operate on inferior substitutes. Detonation, power loss, and overheating became routine. American aircraft compensated for fuel variability with conservative engine tuning and robust cooling margins. Japanese copied designs did not have that luxury. The result was a cruel paradox. The harder pilots pushed these aircraft to match American performance, the closer they came to destroying themselves. Training could no longer compensate. By this stage of the war, new Japanese pilots were arriving at frontline units with minimal flight hours. Many had never flown at the speeds these new aircraft demanded. Emergency procedures were learned in theory, not practice. There was little time to build familiarity with machines that already inspired distrust. In contrast, American pilots transitioned into new aircraft through structured training programs, with time to explore limits safely before combat. What appeared as similar aircraft on paper existed in entirely different operational realities. Even cockpit philosophy reflected this divide. American designs increasingly emphasized pilot survivability, armor protection, self-sealing fuel tanks, reliable radios, and predictable handling under stress. Japanese copied designs often inherited the outward form of these aircraft without fully replicating their internal safeguards. Weight limitations and production pressure stripped away protections deemed non-essential. The message to pilots was unspoken but clear. The aircraft was expendable, So were they. Reports began to circulate through command channels, describing alarming accident rates during training and ferry flights. Aircraft lost not to enemy fire, but to mechanical failure. Wings that failed during high-speed dives, engines that seized mid-flight, fires that spread too quickly to escape. Still, the aircraft remained in development and deployment, because the alternative was worse. Japan's leadership understood that without an answer to American air power, even a flawed won the war in the air was already lost, and so these machines were accepted, assigned, and flown, despite the fear they inspired. By late 1944, the stage was set. A copied American idea had been forced into an environment it was never meant to survive. What was designed as a solution was about to reveal itself as something else entirely. A failure so dangerous that its reputation would spread faster than any enemy intelligence report. And when these aircraft finally met combat conditions, the truth could no longer be hidden. On paper, the copied design looked convincing. Streamlined fuselage, heavier armament, higher theoretical speed. The silhouette suggested modernity in answer to American fighters that had come to dominate the skies. But technology does not exist in isolation. It functions as a chain, and in this aircraft, several links were already failing. The core problem was imbalance. Weight increased faster than power. Additional guns, ammunition, and structural reinforcement were added to match American specifications. But the engine beneath the cowling could not compensate. Performance figures achieved in controlled tests vanished under combat conditions. Climb rates suffered. Acceleration lagged. At high speed, stability degraded instead of improving. Cooling systems proved especially fragile. Long interceptions demanded sustained engine output, yet overheating forced pilots to throttle back precisely when power was needed most. The cockpit design demanded an engine ecosystem Japan could no longer provide. What looked like technological progress was, in reality, a fragile imitation one that punished any attempt to use it aggressively. Pilots feared this aircraft before they ever encountered the enemy. They talked quietly on the ground, compared notes. After test flights, shared stories of unexplained vibrations, control stiffness, and engines that behaved unpredictably. Confidence essential in air, combat eroded quickly. Some pilots requested reassignment. Others accepted their orders in silence. In combat, hesitation was deadly. Pilots avoided pushing the aircraft to its limits, knowing that high-speed dives or abrupt maneuvers might tear the machine apart. Dogfights became acts of restraint rather than aggression. Every maneuver carried a second calculation. Will this defeat the enemy? But will the aircraft survive? Fear did not come from enemy guns. It came from the cockpit itself. Factories were expected to deliver miracles with shrinking resources. Air raids disrupted production lines. Skilled workers were drafted or killed. Replacement labor lacked experience. Quality control deteriorated. Components that once met strict tolerances were now acceptable if they fit at all. Engineers knew the risks, but had no authority to delay production. The Kapiti design demanded precision manufacturing. Japan could only offer approximation. Each aircraft left the factory slightly different from the last. Maintenance crews struggled to keep them operational. Spare parts were scarce. Failures multiplied. This was not sabotage or incompetence, it was exhaustion. Ironically, American pilots rarely feared this aircraft. When encountered, it failed to alter established tactics. Its strengths were inconsistent. Its weaknesses predictable. U.S. intelligence reports noted its existence, but not with alarm. It did not change the balance of power. The true terror remained internal. An aircraft meant to challenge American dominance instead became a symbol of desperation and enemy that Japan had created for itself. By the final year of the war, Japanese aviation leadership was operating in a space where honesty had become dangerous. Reports that emphasized failure risked being interpreted as defeatism. Commanders understood the aircraft's limitations, but they also understood the political reality. Acknowledging that a new fighter was fundamentally flawed meant admitting that there were no better alternatives. Orders were issued not because confidence existed, but because paralysis was unacceptable. Field commanders were instructed to use the aircraft within its limits, a phrase that sounded reasonable until translated into combat reality. Intercepting high-altitude bombers demanded speed, climb, and sustained power, precisely the conditions under which the aircraft performed worst. Leadership knew this contradiction. They lived with it. Instead of redesign, doctrine shifted. Missions were shortened. Pilots were told to avoid prolonged engagements. Some units quietly restricted certain maneuvers altogether. These were not official changes, but adaptations born from survival. In effect, leadership accepted fear as part of the operating environment. The aircraft was no longer a solution. It was a compromise, one that leadership hoped might delay defeat, even briefly. Perhaps the most devastating consequence was not technical, but moral. Earlier in the war, Japanese pilots trusted their machines. Aircraft were extensions of skill and discipline. By late 1944, that trust had fractured. Pilots were being asked to fly machines they believed were unsafe, against enemies whose aircraft were increasingly reliable and forgiving. This knowledge changed behavior. Some pilots flew conservatively, knowing aggression might be fatal. Others embraced fatalism, treating missions as one-way journeys regardless of outcome. In extreme cases, aircraft originally intended as interceptors were quietly redirected toward suicidal roles, not because they were ideal for them, but because their survival prospects were already considered minimal. Fear became institutionalized. When an aircraft inspires more anxiety than the enemy it faces, it has crossed a line. It is no longer a weapon. It is a liability that consumes morale, experience, and lives at an accelerating rate. And by the time leadership fully grasped the depth of this collapse, the aircraft was already committed to combat. The Cockpit idea had reached its moment of truth. What followed would define its legacy not as a counter to American air power, but as one of the most feared failures in aviation history. The moment of truth arrived, not in theory, but in the air. By early 1945, the aircraft was no longer confined to test flights and guarded evaluations. It was assigned to operational units tasked with intercepting American bombers approaching the Japanese home islands. Missions were judged successful not by enemy losses, but by whether pilots returned alive. Maintenance crews struggled to keep pace. Aircraft returned riddled not just with bullet holes, but with mechanical failures. Engines required constant attention. Structural components showed signs of fatigue after only a handful of sorties. Ground crews cannibalized damaged aircraft to keep others flying, further reducing an already shrinking fleet. Despite this, deployment continued. Leadership had no alternative. Interception units were ordered back into the air repeatedly. Even as confidence eroded, the aircraft's reputation spread faster than any official directive. Pilots assigned to the type understood the risk immediately. Some requested transfers. Most did not. There was nowhere else to go. By mid-1945, the aircraft had acquired a grim nickname among crews, one that reflected fear rather than respect. It was spoken quietly, never an official correspondence. The name did not celebrate speed or firepower. It acknowledged danger. The decisive realization came too late. Engineers reviewing combat data could no longer dismiss failures as isolated incidents. The pattern was clear. The Cockpit design had reached the limits of what Japan's industrial base could support. No amount of pilot skill or bravery could compensate for the mismatch between ambition and reality. Yet the aircraft remained in service, because the sky over Japan was no longer a battlefield, it was a countdown. And as American bombers continued to arrive in ever greater numbers, the final test approached, the moment when even fear would no longer restrain pilots from pushing these machines beyond their breaking point. What followed would seal the aircraft's place in history. As the tempo of American bombing intensified, restraint disappeared. There was no longer space for caution, doctrine, or mechanical sympathy. Pilots were ordered to intercept regardless of conditions, regardless of fatigue, regardless of what experience had already proven. The aircraft was now being flown at the edge of its existence. Scrambles came at all hours. Engines were started cold and pushed immediately to maximum output. Pilots climbed harder and faster than design limits allowed, because failing to reach the bombers meant watching cities burn from below. In these conditions, failures multiplied rapidly. Engines overheated within minutes. Power dropped suddenly at altitude. Some pilots reported complete loss of control response during high-speed dives, as airflow overstressed control surfaces caused them to lock or oscillate violently. Recovery was not always possible. Several aircraft disintegrated in mid-air. These were not dramatic explosions. They were structural failures, wings tearing away under stress, tail sections failing during recovery from dives. In many cases, there was no radio call, no warning. The aircraft simply vanished from formation. Other pilots witnessed it and said nothing over the radio. There was nothing to say. When American fighters engaged, the situation became even more desperate. To survive, Japanese pilots needed to maneuver aggressively, but every hard turn risked overstressing the airframe. Every dive risked catastrophic vibration. Pilots found themselves flying straight and predictable paths, an invitation to be shot down because the alternative was potentially worse. Losses accelerated, not only from enemy fire, but from the aircraft itself. Command reports began to blur the distinction between combat and non-combat losses. Aircraft were listed as failed to return without further explanation. Maintenance units quietly stopped questioning why. By this stage, the aircraft's reputation had solidified. Pilots assigned to it understood that survival depended less on skill than on restraint and luck. Some deliberately limited engine output, accepting reduced performance in exchange for a chance to land. Others pushed their machines mercilessly, preferring certainty over prolonged fear. Neither approach changed the outcome. The copied design had become a trap. It demanded conditions Japan could not provide and punished pilots for attempting to meet its theoretical potential. The more desperately it was used, the more dangerous it became. Eventually, even leadership could no longer ignore the data. Operational readiness fell sharply. Serviceability rates collapsed. Aircraft grounded for inspection often never flew again. Replacement airframes arrived with the same flaws as the ones they replaced. There was no fix that could be implemented in time, even if resources had existed. By the final months of the war, the aircraft was no longer expected to change the course of the air war. Its purpose narrowed to one grim function: delay. 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 The bombers delay destruction. Delay the inevitable. In doing so, it consumed pilots at an accelerating pace. What had begun as an attempt to copy American success ended as a symbol of systemic failure. A machine, feared by those who flew it, mistrusted by those who maintained it, and ignored by the enemy it was meant to challenge. When Japan finally began withdrawing the aircraft from frontline roles, the decision came not from strategic reconsideration, but from exhaustion. There were too few pilots left, willing or able to fly it. Too few spare parts. Too little time. Its legacy was sealed, not as a marvel of engineering, not as a worthy opponent, but as a warning. And when the war ended, the wreckage scattered across airfields and crash sites told the story more honestly than any report ever could. The question was no longer how the aircraft failed. It was what that failure would mean once the fighting stopped. When the fighting began to slow and the skies over Japan fell silent, the aircraft's true cost emerged not in headlines or victory claims, but in ledgers, maintenance logs, and casualty lists. Stripped of urgency, the numbers told a story that combat reports never fully captured. Losses attributed to the aircraft were disproportionate to its operational lifespan. Accident rates remained high, even when combat intensity declined. Aircraft were written off after only a handful of sorties. Engines required